Okay, so in this lecture, I want to talk about the section 6.5 of your book, which is the average value of a function. When you talk about averages, of course, you guys know if you had just like 5 numbers and you wanted to find the average of them, you just add them together and then you divide it by the number. So if you have 5 things, then you would average of it would be the sum of them, the total divided by the number of items. It's 10 things divided by 10 and so forth. But for functions, the continuous nature of them doesn't allow you to do that. But you can still do something similar to that to calculate the averages. And again, it's probably something you would have come up with to yourself if you were the first one looking at this idea. So the thing is, you have a function, so you have f of x, and f of x has ups and downs in it. The point of finding an f average is you're just saying, well, okay, if I have this f of x, and if it is the area under the curve is something, can I find a value for f throughout? So the value under the area under that curve is the same as the value, the area under the curve f. So basically the rectangle region has the same area as the region below f of x. That number, whatever that is called your f average. Basically, if you're thinking about it, like if you were going to make a peanut butter sandwich in the morning and you put the peanut butter on your toast, and think about it in a two-dimensional sense, and then you get your knife and you just smooth out the peanut butter. You're not changing how much peanut butter you had, but you're changing the level, so now everything is evened out. Same idea. So you're just basically figuring out where would the f average be. So now the area of the rectangle that you have, if this is from A to B, the area of the rectangle would be f average, which is your height, times b minus a. And you want that to be equal to area of the shaded red region, which is integral from A to B, integral from A to B of f of x dx. From here, you get just basically f average is 1 over b minus a integral from A to B f of x dx. It could be as simple as find the average find the average value of function f of x equal to x squared over the length negative 1 to 3. So obviously, this is what the x squared looks like. This is what negative 1 is. This is what 3 is. So you want to figure out what would be the average value of this. So the area under the curve matches the area under the straight line. So you apply the formula, you get 1 over f average is equal to 1 over b minus a, integral from A to B of f of x dx, which is 1 over 4, 1/3 x cubed from negative 1 to 3, which is 1/12, 27 plus 1, which is 28/12. Which is 7/3. So the average value would be 7/3, which is about 2 something, 2 1/3. So now there is an intermediate value, there's a mean value theorem for integrals, which says what there should exist if your function is continuous. If you have a continuous function and over a closed interval, then you should be able to find a point in that interval, let's call it C, where the value of C, the value function at C is your F average. So F average is equal to F of C for some C in the interval -1, 3. Okay, could be one of the endpoints or it could be something in between. So if I was going to do that, I would say 7/3 is equal to C squared because that's what my F of X is. So that means C is equal to plus or minus square root of 7/3. Now the -1 is not correct because square root of 7/3 as it is 2 something, and negative square root of that would be here, which is not good. But square root of 7/3 does make sense. And that's a value of the value at which the function is the average value of function. So that's a C from the mean value theorem for integrals. So that's how you find the C. You could have multiple C's, yes, but the existence of one of them is guaranteed. As I said, under the condition that you have a continuous function over a closed interval. That's the problem from the homework. Let's do number 9. So it gives you a function f of x equal to x minus 3 squared over 2 to 5, interval 2 to 5. Now, of course, the graph of this is pretty straightforward. And 2 is here, 5 would be here. At 2, the value of function, of course, is 1. At 5, the value of function would be 4. Maybe, yeah. Anyways, so the area you want on this is very similar to the graph I had earlier, but the area under this, you want it to be equal to some average value. The area underneath some average value. So F average is 1 over 5 minus 2, integral from 2 to 5 of x minus 3 squared. If nothing else, this is a nice substitution example. The x, you get 1 over 3, 1/3 x minus 3 is cubed. If I do a u sub, and then that goes from 2 to 5. So that's F average. My drawing is not to scale, but. And then if you want to find, as it says, find C such that F average is F of C. Then F of C would be C minus 3 squared. You want it to be F average. So C minus 3 would have to be plus or minus 1. C would have to be 3 plus or minus 1. So it's either 4 or 2. When you look at your drawing, 2 is here, 4 is here. So basically it would, sorry. This is the actual correct line for this graph. So the other line that I drew is not a great approximation, but at the same time, I think when you're starting to graph it, you probably want to approximate it, and then once you have a better answer, a better exact values, then you will put it. And this, the value of C happens at 4 and 2. So 2 and 4 both satisfy the conditions of the mean value theorem. I had to make some correction there, so there was maybe a hesitant break in the recording. Apologies for that. Okay, so I'll let you guys look at the homework. It's really a very small, short section. It's not a very complicated section, but I'll let you guys play with that a little bit. And then if you have any homework, just like other sections, just post them, and then after I finish 7.1 lecture, which is going to be very soon, then we can go over some homework problems for you guys to get you all set up for the homework. I don't do the homework sessions early in the week because I want to give you guys some chance to play with them first, and then I give you guys my version of my approach to them. But we'll for sure before the deadline we will have a problem session for us to go over some of the problems. I've been going through some of the problems as I do the lectures, so I'm just waiting to see what other problems you guys want me to look at. So we'll do that as well. So that should be helpful to you. So, okay, I hope you enjoyed this one too, and I'll see you guys in the next video. Bye.